Welcome back. This is mini lecture number 13 for Computer Science 163 at the University of Wisconsin-Eau Claire. We'll be talking in this mini lecture about formatting input and output using stream manipulators. So this is section 8.3 in your textbook. If you've already read your textbook or you feel comfortable with file input and output because you've either done it before, maybe in a different language, or you feel really comfortable with the material from the last mini lecture, done the example problems or so, one or two of them, then you're probably fine. But if not, I encourage you to check these out. Here is the diagram of streams. As always, we say for an input stream, that's data coming into your program from usually a keyboard via CN or a file via an IF stream. And then output streams will take data from your program and bring them either to the screen, like cout, or to a file via an OF stream. Now, stream manipulators are basically ways to manipulate, go figure, right? They're things that will format, they'll control a lot of things, but they basically manipulate the stream in some way or another by changing some of the settings or usually formatting, but there's a few other things they can do as well. Now, if you want a nice little table, Table 2, page 362 is great, but here's a couple of the main purposes, big picture level. But otherwise, that Table 2 has good examples and shows you, it really does a good job of showing you what's up. So stream manipulators are often used for formatting text. You might say that's one of their primary purposes. It usually is things like padding, filling, or aligning text, handling whitespace for input, usually, sometimes output too. It's used for specifying output format for numbers. So for instance, how many digits of precision do you want? Do you want to express it in a fixed point notation or scientific notation? Do you want to include the sign? Like, a negative number will always have the negative in front of it, but do you want to force positive numbers to have the positive sign in front of them? Stream manipulators are also useful for controlling the stream in other ways. For instance, whether or not to flush the stream. They can also add other characters as well. Now we'll talk about what flushing means in just a little bit, but for now, you can do that. Stream manipulators can also be used together to achieve certain goals as well, and we'll see examples of that towards the end of this mini lecture. Stream manipulators can format text. Here's our first example, SetW. Now this is a function that how it gets passed exactly is a little complicated, but basically what you're going to do with stream manipulators is you're going to insert them into a stream. So if it's to an output stream, you will put them in between, let's see, if it's output stream, you will put them in between the insertion operators, like you would just a regular piece of text to be output. And same for an insertion operator, you'll put them in between the greater than operator. So SetW sets the width in characters of the next output operation. So let's see an example of that. So if the code is cout less than 36, it just prints 36. No spaces, no white space. If we do cout with the stream manipulator SetW, we have to pass it a number of characters that we want it to pad, and then we also need to include it with the output stream extraction operators. So just put it in there like that. And it's basically feeding the stream and saying, here's some instructions for the next output operation. That's kind of how you think about it. You're basically telling the stream what to do by feeding it this function, which does cool things. Now notice here on the right-hand side, the output, now there are 5 characters. There's 3 spaces and then a 3 and a 6, whereas before there was just the 3 and the 6. So if you want a certain number of spaces or columns or whatever in your file, this is a way to do it. Now to do this, you need to include the header file called iomanip for input-output manipulator. And some of the other ones you do as well. Some of them are found elsewhere, and we'll see some other examples of those as well. Stream manipulators, another one that we can see is SetFill. In this case, SetFill, you're giving it 0, which means you're going to fill with zeros. And this sets the fill character for padding a field of fixed width. So if you've already done set width and you're saying, I want there to be this big old field, or like, 5 characters, and you put a 36 in, this will now zero pad them. But you could do it with other characters as well. So for instance, if we do set width 5 and then 36, that means we're going to output a string of 36 or 5 characters, and the last 2 of which will be 36. Now, if we add SetFill in there with a 0, then that means that it will zero pad them, which means that it will fill that empty space with the character 0. It's not the number 0, it's the character 0. I could have just as easily done another character as well. For instance, the dot character, period. So here we still set W, we want 5 characters output in the next operation. SetFill is saying it's not an output operation, it's an output manipulator, so it doesn't count for the next operation that setWidth has to do. But SetFill will then fill it up with periods. Another stream manipulator are the right and left manipulators, and this just sets the alignment for a field of fixed width. So again, we have a fixed width, SetW, of 5, and we output, instead of a number this time, we output text. And that would have worked for the other 2 as well. So here we're putting out high, and we're aligning high to the right. Here we align high to the left, and it outputs high on the left-hand side there. And again, it's padding with spaces, but you could also use SetFill to pad it with any other text that you want. Another stream manipulator are the uppercase and no uppercase ones. Oddly enough, there's no lowercase or no lowercase, but there is uppercase because it's used a little bit more often in computer programming. Uppercase will force all characters to be uppercase. It'll basically turn on a flag, and so anything else that you use that stream with, any other characters, letters that you print to the screen, they will all be uppercase. Until you either close that stream or you turn that behavior off by setting no uppercase. And then if you send a mix of uppercase and lowercase, it goes back to normal. So for instance, we output hello, this is what you get. You output hello with after the uppercase manipulator, and now you get hello. And then you output hello now again, and it's still uppercase because that flag is set in that iostream. Now you tell it no uppercase, and it goes back to normal. And you do another one, and it's still normal. So that's how the uppercase and no uppercase stream manipulators work. The next stream manipulator that we'll look at is the showPos manipulator. This forces numbers to have positive signs. So for instance, if I output -9 to cout, and then 14, it outputs -9, 14, just like I've told it to. And now if I do showPos, now it's going to add the plus sign to the stream. So that means that number is going to take up an extra character because the plus sign is part of that number now. Of course, it's not a numeral, but you get the idea. And the next one are the DeskAcht and Hex Formatting stream manipulators. What these do is they tell the stream how to express integer numbers. So for instance, and other ones as well, non-integers. So you can express numbers using the decimal system, which we are used to. You can also express them using octal system or hexadecimal systems as well. And this is useful because those other 2 systems, the hexadecimal system can fit a lot more information per character than the decimal system. So that if you have a big number, it can be represented more compactly using hexadecimal. And you see that often for other things like colors and memory addresses and other stuff. So for example, if we output 99, we get the string 99. If we output des and then 99, we get 99 because 99 is a decimal. If we output oct 99, we get 143, which represents 3 times 8 to the 0 power plus 4 times 8 to the first power plus 1 times 8 squared. So that's the octal system. You can read about that if you want. Hexadecimal system, 99 can be represented like this. 3 times 16 to the 0 power plus 6 times 16 to the first power. So 6 times 16 plus 3 is 99. Next, we have SetPrecision, another formatting number stream manipulator. Here you have to give it n, which is the number of significant digits, and how it's defined is exactly is a little bit tricky, so you can always double check how that's defined if you're using it. To be honest, whenever I use these stream manipulators, I almost always have to look them up. I just don't use them quite often enough because I'm not quite often enough doing input and output with C++. I do it with Fortran and MATLAB a little bit more, but even then, in other languages too, I always have to look up how to format things, and every language does it just slightly differently. This is how C++ does it. So by default, C++ will, if you give it tell it to output a float or a double, it will output 6 significant digits or precision of 6. So for instance, if we define a constant pi, double, like that, then if I output it, it will by default just output this, 6 digits of precision. If I say set precision 3, it outputs 3.14. If I say set precision 10 and then output pi, it gives me 10 digits. Cool. How do you handle whitespace? Skip WS and no skip WS. So skip whitespace or don't skip whitespace. This is mostly used for input streams, whereas all the others have been for output streams, generally, not always, but generally. Now, this is really just for an input stream. So if you're reading in from a file and you want to read an entire line, or you want to read multiple words, you can say skip WS or no skip WS. By default, you skip skip whitespace, but you can also say don't skip the whitespace. That's part of the string, for instance, that you read in. So again, the default is to skip. So let's say you have 3 characters, A1, A2, and A3, and you have another 3 characters, B1, B2, and B3. Let's say that you're reading in from the stream, say cin, but it could also be from a file. And but let's say it's from the keyboard. So the user enters it to cin 1 space 2 space 3, enter. And then we do cin and then skip whitespace and then A1, A2, A3. The result will be A1 is the character 1, A2 is the character 2, and A3 is the character 3. That's the default behavior. What's happening is whenever you read from an input stream, by default it's going to skip the white space in between the characters. So when the user enters 1 space 2 space 3, it's skipping over the spaces and just looking at the words. And here it's just inputting a character, not even a string. So it's just a character. Now, if we do no skip white space and then read from that same thing and the user says 1 space 2 space 3 again, now if we extract from that stream no skip white space and then B1, B2, B3, what do you suppose we'll get? Let's pause for a sec. Here's what you'd get. It would read the 1 as a character, it would not skip the space, it would read B2 as what is the next character in the stream, which is the space, and then it would read the next character, which is the 2. Cool. To understand the next output operator, flush, we need to understand what exactly is happening underneath the hood and how an iostream works. So let's take an output stream for instance. In an output stream, data flows from your program through the stream, represented by the arrow, to either the screen, if it's cout, or to a file, if it's an OF stream, an output file stream. Now, it's not actually going to go straight from your program to the screen or a file through the stream. It's actually going to stay in the stream for a while, and then when the computer decides it's found a good time, to do it, it'll then output it. So it basically, the stream keeps it in an internal buffer or temporary storage space inside of the stream until it's ready to flush everything out at once. And so it's kind of just, it's like, it takes a bunch of data, fills up with more data, fills up with more data, and then when it decides, this is enough data, or now is a time when the computer's not working too hard, then it opens up, and then the stream is allowed to keep moving all the way to the screen of the file. But in the meantime, the data has left the program and has gone to the stream, but until you flush it, it stays in the stream and hasn't gone quite to the screen of the file. Now the computer will automatically determine when to flush sometimes, but you can also tell it to flush. Now, So basically what does a flush do? It tells the stream to move its contents from temporary storage inside of itself to its destination immediately. You can kind of think of it like the stream isn't flowing until you tell it to flush. Now the stream flows, now all the data actually gets to its destination. I wanted to give you guys an example of how the flush operator works. So to do this, I've designed this kind of silly little experiment code, which I encourage you to play around with and to really understand. We're going to include 3 header files. Chrono is timing, thread is sleeping. Don't worry about that for now. We're going to define 3 constants, and then I'll explain what these do in just a sec. I'm also going to explain to the user what's going on. So if you download this program on our website, then you can do it yourself, and it will tell you every time you run the program. So we're going to count to iterations, so 30 iterations, at 1 second intervals. So it's going to print to the screen 1, 2, 3, 4, 5, 6. But it's going to add a new line after every new line entry. So in this case, it's going to add a new line every 10 entries. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, new line. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, new line, and then so on. But then it's also going to only flush every, in this case, 2 iterations. So it's going to, well, we'll see in just a little bit. So this is the first output statement. Also, you notice how we have this thing called endLine or endL? Do you have an idea of what kind of object that might be? It's an IO manipulator, just like flush, but a little bit different. So here are, here's the loop. We're going to go through this in, as we said before, 30 iterations, though you could change that. And every iteration, we're going to output the iteration number. So right here, we're just going to output space and then 1, space 2, space 3, space 4 for every iteration through this loop. And at the end of each iteration, we're going to sleep for 1 second. Don't worry about this fancy code. We haven't learned it. I hadn't learned it, but you can do this if you want to. Yeah, I looked it up, how to do it. Pretty easy. So it's going to go space 1, rest, space 2, rest, space 3, rest, space 4, rest. And so every rest, it's going to pause before it outputs the next thing. At the very end, we're going to output a new line, and endL is a manipulator which both outputs a new line and it flushes. So it's going to make sure all the output is synchronized, it's going to make sure all the output was written to the screen, then we'll return 0 and end that whole function, this main method. Now what's in the middle of this, this thing? What about the flush and what about the skipping iterations? If I mod new line entry equals 0, remember the modulus operator basically says I divided by new line entry, what's the remainder of that? So if new line entry was every 10, so what this is going to do is every 10 lines, if I divided by 10 is an even number with 0 remainder, then output n and a new line. Now originally I just had it print out a new line, but then I figured let's actually print out the character n so we can see where those new lines are happening, and then output the new line. So every 10 iterations it'll output a new line and the character n, and then every I% flush every, flush every was 2 before, so every 2 iterations we want to output the character f and flush. So we're going to basically say, let's output the character f, and then flush, we're going to synchronize it. And then pause for a second, and then go to the next iteration. So I really encourage you to download this code from our website, and then actually run it. It's pretty cool. And I hope that from seeing this, you'll be able to understand what flushing means and for an IO stream, and how you might use it. Basically, you don't need to use it that often, but it's good to know, and you do want to make sure that you do it for your endL. If you go too long without flushing your output, then what can happen is if your program suddenly exits and it hasn't flushed your output, then maybe it won't actually get to, to do your output. You won't get to see everything that it should have written. Now, if you exit the program normally, it will make, one of the things that it does when you exit a C++ program is it actually calls another function, one that you don't return from. and that function will call some other things, and it will do some cleanup for your program. There's a lot of cleanup-y things that you can do for a program, and one of them is to make sure that all input and output has been synchronized, all files have been closed, all memory has been returned to the computer, and various other little cleanup-y tasks. So it'll make sure that it does it. But if your program aborts abnormally and you haven't flushed your output in a long time, then the output will just disappear and it won't ever get to the screen. So that's the end of that example. And here are some review questions, and if you skip forward 2 slides to the end of this mini lecture, you'll see the answers, but please don't. Please make sure you get a chance to go through these yourself to test your understanding, and if you're not sure, rather than looking at the answers, go back and look, challenge yourself, and see if you can look, because these are the kinds of questions that I could have on the next mini quiz or the next exam. For a challenge problem, I made a data file based on some of the data that I used for my dissertation. So one of the models that I do in my dissertation is I model Saturn's upper atmosphere in various certain circumstances, certain setup, and one of the variables that I output is this 3D grid in latitude, longitude, and in height of the different eastward winds. So that is a variable called Fy, and then there's a model name there in this file. Now, so this is the eastward winds from Saturn's upper atmosphere in meters per second from this one model, predictions. So under the hood in Fortran, this was a 3D array, and the dimensions were 36 in the first dimension for height, 91 in the middle dimension for latitude, and then 36 in the east-west longitude dimension. So I challenge you to read in the contents of that text file as a 3D array. So you can do that in your main method, you could write a function, and at the end, to see if you have read it incorrectly, try calculating the average value of that whole 3D array. Just each, no special weighting or anything, just all of the values in that whole array. What's the average value of all of them? So you could sum all of them up together, divided by the total number of elements, and I got negative 202.02 meters per second. So I have made some code that will be posted on Canvas as well to accompany this, but give it a shot. And if you want, my code there also does this in binary. So it will, if you want to see how to read and write things in binary, it's good example code to show you how to do that. And I encourage you to write a program for every new computer programming language that you learn. Write a program and just keep functions for write a 1D array to a file, write a 2D array to a file, read a 1D array from a file, read a 2D array from a file. Do that for both binary and for ASCII files, text files, and you'll be good. That's what a lot of things that you need to do in science can be done using just those 2 functions. Finally, if you're still with me, thank you for your attention. But here are the answers to today's review questions. So if you have any questions about these answers, or if you want to know anything more or go deeper, let me know. I'd love to help you out, and I hope that you have that you enjoyed this, that you learned from it, and that it was useful to you and worth your time. And I will see you for the next mini lecture, hopefully. Take care, and just have